All right, so section 5.2 is congruent polygons. So a rigid motion maps each part of a figure to a corresponding part of its image. In congruent polygons, this means that corresponding sides and corresponding angles are congruent. So example 1, write a congruent statement for the triangles. Identify all the pairs of corresponding parts. So remember, when we're talking about a congruent statement for all the corresponding parts, we have 3 sides of a triangle, we have 3 angles of a triangle. So we'll have a total of 6 corresponding parts here. So what I suggest here is you might transform. One of the triangles to help identify corresponding parts. So now remember, that could be a rotation, that could be a reflection, or that could be a translation. So on this one here, I'm going to tell you we're going to rotate. So we're going to rotate here. All right, so I kept the top one the same. And again, when you draw them, they don't have to be perfect. They just have to have the same corresponding part. So I'm going to keep this one here as M, N, and P. And then they have one side here, 2 tick marks here, and 3 here. All right, so now I'm going to rotate the bottom one. So if I rotate the bottom one, well, it looks like, again, just draw a triangle. That looks the same. Doesn't have to be perfect. But then look at the one. We have one angle mark here, one arc. Where's the one that has only one arc on this one? That'll be Z. All right, which one has 2? Because again, we want it to correspond with the M. So if we look at that, which one has 2? And you would tell me it would be Y. And then the X would be up here, and X has 3 arcs. So now hopefully if we did this right, our corresponding sides should be the same. So MN, we should have, that would be the same with one tick mark on that would be XY or YX in this case, and that is true. And ZX or XZ is right there. And then of course the bottom one will still have 3 tick marks. All right, so now what that means is we are going to now have a congruent statement. So our congruent statement So our congruent statement is if I follow here, now look at what I did. I'm going to start at M. So I went through 1. I went through the one that is tick marked 2. Then I'm going to go through the one that is tick marked 3. So I'm going to say my congruent statement here is triangle MNP is congruent, and we're going to do the same pattern. So again, 1 tick mark, 2 tick marks, 3 tick marks. So it will be congruent to triangle YXZ. And now that we have everything in order, we can now find out what our corresponding angles are and what our corresponding sides are. So our corresponding angles, and again, just look at the ones that have the same ones. So if I say M, and again, I don't have to necessarily go in order here. So if I say angle M, well, that is congruent to angle Y. I can say that angle P is congruent to angle Z. And let's see, what one don't I have? Angle N is congruent to angle X. Okay, so those do have to be sort of following, and the corresponding sides the same thing. So if I look, and again, I'm going to follow my rotation that I did, ladies and gentlemen. So if I tell you MN, remember, since it's congruent, I know I have to talk about the line segment. Line segment MN is congruent to line segment YX, and we have to follow the same rotation. NP, which has 2 tick marks, is congruent to XZ, again, line segments, because we're not talking about length or distance. And finally, then the last one here I have is I have PM is congruent to ZY. And those are in order, okay? And that's going to be important. We're going to have the same thing. So on this one here, you can always see, ladies and gentlemen, if you're not sure, follow the order that you made them. So if we look, MN and YZ would be together, right? Angle M here would be corresponding to the angle Y there. All right, so remember that, because sometimes if you don't rotate them, you can at least kind of see what happens, like on our next example here. So in the diagram, DEFG is congruent to QMNP. Find the value of X and Y. All right, so if we look at it, they said DE, all right, because I have DE is equal to 8 feet. And I should have something, if that was the same, I should have something with QM, which I do. All right. So we would be able to say that on that one, DE is congruent to QM. That would be the line segments, right? So since we know that the line segments are congruent, we know that the side lengths have to be equal. So we can say that DE is equal to QM. And if that's the case, we can say that 8, which is our length for DE, is equal to X minus 2 for QM. And we're just going to solve that for X. And I would add 2 to both sides. So I'll get that X is equal to 10. Okay, so now let's see here. Kind of look at the one that we know we need. So we know we need angle P. So we know we need this angle here. And which is the one that is associated with it? So there's my P. What is associated with it? That would be angle G, right? So this one would be associated with it. So what does that tell us? Again, well, let's write it down. Angle G is congruent to angle P, which means that the measure of angle G is equal to the measure of angle P. The measure of angle G is 84. The measure of angle P is equal to 3x plus 2y. Now that should tell you why I did the first one first, because notice on this one here I have an x and a y, but I solved the side lengths for x, so I'll be able to use that right now. So I'll be able to say 84 is equal to 3 times 10 plus 2y. So 84 is equal to 30 plus 2y. I'm going to subtract 30 from both sides of the equal sign. So that would tell me that I'm going to have 54 on this side. I'll have 2y on this side. If I divide by 2, 54 divided by 2, it will be 27. And there are both ones right there. Okay, I'm just kind of doing all the ones that I know our homework has. So we have one like that too. Okay. So our next example on this one here says show that triangle ABD is congruent to triangle CDB and to explain your reasoning. All right, so now they're gonna have to tell me some things that you know. All right, and some of these things you'll probably have forgotten from earlier chapters, but again, I always say mark what you know. All right, well, in this case here, they mark these two here, right? So we know that those two have to be equal. So let's say from the diagram, you can tell me that AD, oh yeah, let's look at this one here and this one here. So those tick marks are the same, right? So you can tell me that AD is congruent to, and look, I went from the one that has one angle to the one that has no mark. So I have to do the same thing on the other one. So I'm going to go from the angle that has one that I had to the one that has nothing. So I would say from the diagram, AD is congruent to line segment CB. And you can also tell me that the other two that I have, so if I say AB, line segment, of course, because we're talking about congruence, and which is that one going, what is it going to be congruent to? So I went from one arc to two arcs, so I have to do the same on the other one. So I would say CD, line segment. So we know those are. Let's see, do we know? Well, we're talking sides, so what about the last side? All right, here is a very important one that you probably forgot. I mentioned it earlier, okay? But we have those two sides are equal. We have those two sides are equal. Well, this side here would equal itself. All right, that's called the reflexive property. So, by the reflexive property, you can tell me that BD is congruent to, now, look at what I said. I went from, well, it's going to be the same anyways, isn't it? Well, I went from 2 to the one that isn't marked. What if I put 3 there? Okay. How would it be on the other triangle? Well, this one here would be 2. So this one here would be 3. So on this one here, we could say that BD is congruent to DB. Now, I'm sure since it is called the reflexive property, ladies and gentlemen, if you said BD is congruent to BD, I'm pretty sure, 90% sure that the homework on the Big Ideas website will let that happen. If not, I would go in and change it on the test. I will guarantee you that. All right. So now we have all the sides are congruent, right? So remember, now I have to show all the angles are congruent. So we know that you can tell me that angle A is congruent to angle C, right? Because they have the same arc measure of 1, right? I mean, just one arc tick. And then you can tell me what's the other one that has 2. You can tell me that angle B is congruent to angle D, right? Now I just told you that this one here and this one here are the same. But can you tell me why, ladies and gentlemen? All right. Can you tell me why? I'll let you think about that as I write down that from these two we can tell from the diagram. Okay, now I want you to think here, ladies and gentlemen. I have 2 lines that are parallel. This line here and this line here are parallel. So remember, I told you parallel lines, we look for angles. So if we look at it here, they told me that this one here is parallel to this one here. What shape did I just make, ladies and gentlemen? You're right, I made a Z, and what is that? That is alternate interior angles, correct? So we can say that given that AD is parallel to BC because of alternate interior angles, we can say that angle, now, what did I do here? Oh, I told you it was B here, but what mistake did I make, ladies and gentlemen? Right? I said angle B. Well, I did that kind of on purpose, kind of not, because I'm in a hurry. But remember, if you said angle B, I would ask which angle B? Would you mean talking about this angle B here or this angle B here? So on this one up here, let me just keep it as green because I'm going to show you that I did make a mistake, right? So on that one there, we should say angle ABD, because that was the one we knew, that was the one with tick marks, is congruent to angle. Again, now look at what I did. I went from 1 to 2. I'm going to have to go from 1 to 2. So I would say CDB. All right. So now we're going to do the same thing for the other one. So let me clean this up a little bit for you. All right, and I fixed my mistake. Yes, I am human, believe it or not. So what are my other ones? So again, what do we want to say? And I was telling you it was this one here and this one here. So if I went angle, let me see, why don't I go A, D, B? Because now notice that is different than a BD, right? So if I went A, D, B, so I went from 1 to the one I marked 3 to the one that's 2. So you're going to tell me that is congruent to, again, we're going to have to do the one that's marked with 1, which is C. I told you we went to the one that was 3, right? So that would be B. And now you can kind of see why I put little arcs in my angles, because my C right there kind of almost looks like an L, doesn't it? So it would be C, B, D. Okay. And now we have shown that all corresponding sides are congruent. Angles. And I say that. So we've just shown all 6 sides, and angles. 3 of each are all congruent. Well, heck, let's go ahead and write that down. Since, and I know it's kind of wordy, but since all sides and all angles are congruent. Yeah, as you're doing the homework, ladies and gentlemen, make sure that you choose the 2 angles that have the same thing. So I'm going to say, if I say triangle, and let me see, why don't I say triangle? Let's go ABD. You're going to tell me that it is congruent to, and look at how I went. I went from 1 arc to 2 arcs to the one that I made 3. So you're going to do the same thing on the other triangle. So there's 1 arc, C, 2 arcs, which is D, and then finally 3 arcs in this one, which is B. And we just proved it. All right, well, we showed it, okay? Technically, kind of proved it too. Excuse me. So, we have one more example after we talk about a few things. The properties of congruence that are true for segments and angles are also true for triangles. So the properties of triangle congruence, again, we can say the reflexive property, that means that a triangle is equal to itself. So if I give you a triangle ABC, it's going to follow the same pattern because it's congruent to itself. So triangle ABC is congruent to triangle ABC. And remember, symmetric means if I say one's congruent one way, I can kind of flip it over and say the other one's congruent the other way. So if triangle ABC is congruent to triangle DEF, then we know that triangle DEF is congruent to triangle ABC. All right. And then finally, the transitive property, I know we've talked about this one before. So if I can say if A is congruent to B and B, because notice my triangle DEF is what I'm calling B, and we did this one, is congruent to C, then we can say by the transitive property that A, in this case our triangle ABC, is congruent to C, all right, which is in this case triangle JKL. Okay, and then this theorem, sometimes some of these theorems, ladies and gentlemen, I know they kind of sound silly, but they need to make sense. So if 2 angles of one triangle are congruent, to two angles of another triangle, then the third angles are also congruent. That means they must be. So since I have, in this case here, I have angle B is congruent to angle E, and I have angle A is congruent to angle D, again, because they're marked the same, then we know by this weird theorem that I can say that angle C is congruent to angle F. And remember, if they're congruent, then we know that their measures are equal. All right, so on this one here, we know what? Find the measure of angle P. All right, so we know that angle A is congruent to angle R because they are marked the same. We know that angle C, which is a right angle, so we know that equals 90 degrees, correct? We know that angle C is congruent to angle Q. So that means that angle B has to be congruent to angle P. All right. So if that's the case, we know that the measure of angle B has to equal the measure of angle P. All right. So now let's just go ahead and think about this. So by the triangle sum theorem, I can say that the measure of angle B, well, let's just go ahead and write it down all at the beginning, right? So we know that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180 degrees. We know that the measure of angle A is 52. We know that the measure of angle C is 90 degrees. So again, that would equal 180. So we know that the measure of angle B, to get it by itself, I have the 180 on the other side, but I would subtract the 90. I would subtract the 52. So we know that the measure of angle B is equal to 38 degrees. So since the measure of angle B is equal to the measure of angle P, we can state that the measure of angle P is equal to 38 degrees. And that's just your algebra there, people. All right, so we're done.